Hi everyone, we are Team Vertex and we have Alan, Evan, Poirier, Ryan, and Tony here, and we will be presenting the Blank OSL.
The Blank OSL is an operating system abstraction layer that utilizes large language model to improve operating systems navigation experiences. With the increasing popularity of GUI-based application, the general public feels less and less incentivized to study and use terminal commands despite its rich functionalities. In addition, certain tasks can be quite complex as it requires domain-specific knowledge. For example, imagine you're a retired plumber who are not very experienced with computers, but you want to visualize your living expenses in the past 12 months. So what would you do? You go on Google, spend 3 hours struggling to learn how to plot the data from a CSV files, and then spend another 5 hours actually implementing it. This is where the Blank OSL comes in and provides solution purely based on users' natural language inputs. The Blank OSL terminal first accepts users' text input. It then structures users' query with the operating system properties and the user's information, sends it to the large language model that we have fine-tuned ahead of the time. The large language model then generates the codes and the corresponding description. The users get to check the purpose of those commands based on the description and confirm if they want to execute those commands. If yes, those codes is then sent it to the abstracted command executor that's platform dependent.
For our team organization, we have 2 weekly stand-ups, each 30 minutes with all team members. Our communication takes place in Discord. We have our ticket tracker and Kanban board on GitHub as seen below, and we have separated the tasks into 3 teams, the UI team, API/LLM, and also the research team for a successful division of responsibility.
From MP1, all we had was an LLM that outputted commands. Then in MP2, we also added additional safeguards to avoid prompt injection. Similarly, in MP3, we made even more improvements on the LLM side of things. The first big improvement we did was modularize the LLM interface into classes. By utilizing classes, this means the input and output of the LLMs can more easily be broken down into consistent formats that is parsed by our UI. Another thing we really focused on was providing user feedback using the LLMs. Specifically, we harnessed an additional model context to provide explanations to any commands outputted as a response to the user query. We utilized a fresh new context to avoid hallucinations in command explanations. This really allows the user to better understand what command will be executed on their device.
The user interface has been revamped to provide a seamless and modern way of interacting with the app. Users can now launch the app instantly using a keyboard shortcut for command execution at any time without distraction. For clarity and to prevent unintended actions, generated commands and description of their expected outcome are displayed in a pop-up confirmation before execution. This feature adds user confidence and control. And let's see how this works in practice. Here's something cool that the app can do. Let's say that I want to plot the graph y equals sine 2x plus x to the power of 2. The app figures it out, shows me the steps in the confirmation box, and draws the plots. Let's run the app and see what it comes up. As you can see, the app basically shows the plot for this specific equation.
Let's start with what went well. So we had great teamwork throughout the project and maintained good communication and division of tasks. Thanks to our team organization, we also came up with brilliant solutions to problems we faced together by brainstorming. And finally, we successfully applied our research review into a great technology, and that was shown by the demo. So some exciting features to come in the future. The first one is we will continue to improve with feedback received. We will also add a speech-to-text feature. We will also explore fine-tuning our own in-house model and continuing the benchmark. And we will also look into LLM-based file systems by implementing a vector database to address privacy concerns. Thank you.